there, Math Hoppers. In this video lesson, we are going to go over solving absolute value equations. All right, so let's review absolute value. Remember that it's a distance, right? It is the distance a number is away from zero. So what does this value mean? The absolute value of x equals 5. This is asking what number or numbers are exactly 5 spaces away from zero. And if we look at a number line, we can clearly see that both -5 and 5 are 5 spaces away from 0. Therefore, the absolute value of x equals 5 gives us two solutions. X equals -5 and x equals 5. Either or will work. So there are two solutions to this equation. Now, I know lots of textbooks say you always get two solutions. But are there always two solutions? This is where I get into a little bit of a thing where I hate when people say always, because always is rarely true. So are there always two solutions? Almost. Let's consider this equation. And this is a rare equation, but let's say someone asked you to solve the absolute value of 2x plus 5 equals 0. All right, so what this is saying is that the expression 2x plus 5 has to be 0 spaces away from 0, right? Because this is the distance. We want to know what numbers are a certain distance from 0. What is the distance? Well, the distance is 0. So in this really weird case, 2x plus 5, or the expression within the absolute value bars, has to be equal to 0. And 0 cannot be positive or negative. It is neither. So for this one, we would set it equal to 0 and solve. So the opposite of adding 5 is subtracting 5. The opposite of multiplying by 2 is dividing by 2. And we would get x equals -5/2. And that would be the only solution for this problem, because there's only one number that has an absolute value of 0, and that is 0. So let's check our solution just to make sure. Throw the absolute value bars back up there, and we have, remember, 2 times x, where x is -5/2, plus 5, and let's see if that has an absolute value of 0. So 2 divided by 2, those cancel. We're left with the absolute value of -5 plus 5 being 0. And -5 plus 5 is 0, and 0 does have an absolute value of 0. Now, in all other cases, if you don't have an absolute value set equal to 0, you will get two solutions. So it's mostly correct when they say they all have two solutions. All right, let's look at this one. What value or values makes this true? The absolute value of x equals -5. This is asking what number or numbers are exactly -5 spaces from 0. So we've talked about absolute value being a distance, and as a measurement, distance will not be negative. So there are no solutions to this. Absolute value is the distance a number is from 0. It can never be negative. Absolute value of x equals -5 has no solution. So when we're solving these, be very careful. Let's say we had another expression over here, like an x plus 2. If we get an answer, we do have to check our answers and make sure that they don't result in a negative, having the absolute value set equal to a negative. So these are some equations that can have extraneous solutions, or solutions that don't really work. And we'll talk about that as we go on. So let's look at this one. This says the absolute value of x minus 6 equals 4. So for the absolute value of this expression to be 4, the expression itself, x minus 6, can either be 4 or -4. So when we solve these, we set them out equal to the right side of the equation and the opposite of the right side of the equation. You could either start with -4 or start with 4. It makes no difference. Just make sure you set the inside equal to 4 and -4. Because if the absolute value of this is going to be 4 distances or 4 spaces from 0, then it can be -4 or 4. Now let's solve them as normal. Opposite of subtract 6 is add 6. X equals 2. Let's solve the other one. Again, adding 6 to both sides, we get x equals 10. Now, I keep talking about absolute value being a distance, and textbooks won't really talk about this, and you probably won't be asked this, but it's important to note that this here, these two answers represent the two values that are 4 spaces away from 6. Okay, so if the absolute value of x minus 6 equals 4, then the answers will be the two values 4 spaces from 6. All right, let's check our solution again. We get 2 minus 6, the absolute value of 2 minus 6 equals 4, and the absolute value of 10 minus 6 equals 4. We're just going to check these, make sure we get answers that make sense. 2 minus 6 is negative 4. The absolute value of negative 4 is 4. 10 minus 6 is positive 4, and positive 4 has an absolute value of 4. Okay, let's get into a two-step problem. When we are solving these, just like we have to solve equations by isolating the variable, we have to isolate the absolute value term. We can't automatically set this equal to positive and negative 15 because we have this negative 4 hanging out here that's getting in the way. So what you have to do is isolate the absolute value bars before you can know what positive and negative value to set the expression equal to. All right, so let's get rid of the negative 4 by adding 4 to both sides. Now we're left with the absolute value of 2x plus 3 equals 19. Now we know the expression 2x plus 3 can either equal 19 or negative 19 because we know it has to have an absolute value of 19. So now we could split it out and solve each equation. So 2x plus 3 equals 19, 2x plus 3 equals negative 19. Let's go ahead and solve the left one first. Subtract 3, you get 2x equals 16. Let's divide by 2 because x still isn't alone, and we get x equals 8. Solving the other one, again subtracting 3 is our first step. 2x equals negative 22. Again we divide by 2, x equals negative 11. All right, checking the solutions, we'll just kind of put the checks up there. We have 2 times x plus 3, all in absolute value bars. So the absolute value of 2 times 8 plus 3 is the absolute value of 16 plus 3. So the absolute value of 19 minus 4, which gives us 19 minus 4, which equals 15, which equals the right side. Let's check the other solution. 2 times negative 11 plus 3, all within the absolute value bar, minus 4 equals 15. So if we just work within the absolute value bar, we get 2 times negative 11 is negative 22. The absolute value of negative 22 plus 3 is negative 19. Absolute value of negative 19 is 19. 19 minus 4 still equals 15. Everything looks good. All right, let's add one more step to an equation. Now we have a multi-step equation. Once you go past 2 steps, we say it's multi-step. Again, we're going to isolate the absolute value expression. Good news is we're going to do it just the way we did it when we solved linear equations. Remember when we worked from the furthest term from the variable to the closest? We always added or subtracted from both sides before multiplying and dividing. We're going to do that again. So we're going to get rid of this plus 3 right here, and we get rid of adding 3 by subtracting 3. That leaves us with 2 times the quantity, the absolute value of x minus 7 equals 20. My absolute value bar still not by itself, so let's get rid of the 2 that's multiplied by dividing it. Now we're left with the absolute value of x minus 7 equals 10. So once again, we now know that the expression x minus 7 can either equal 10 or negative 10 to give us an absolute value of 10. So let's split it out, set it equal to 10 and negative 10, and let's solve the one on the left first. X minus 7 equals 10. Get rid of the minus 7 by adding 7 to both sides. We get x equals 17. Solving the other one, x minus 7 equals negative 10. Again, we have to add 7 to both sides. X equals negative 3. All right, let's check our solutions. Pop them in there. If we have 2 times the absolute value of 17 minus 7, the absolute value of 17 minus 7 is the absolute value of 10. Absolute value of 10 is 10. 2 times 10 is 20, plus 3 is 23. 23 does in fact equal 23. Checking the other solution, let's see. 2 times the quantity, the absolute value of negative 3 minus 7, gives us a negative 10, right? Negative 3 plus negative 7. So the absolute value of negative 10 is 10. 2 times 10 is 20, plus 3 is 23. Both solutions work. All right, one more. This time we do not have our absolute value bar isolated, even if it looks like we do. This negative right outside these bars, remember that represents a negative 1 being multiplied to this entire expression. So we have to get rid of that. How do we get rid of that? We have to divide both sides by negative 1. When you divide by negative 1, you're just changing the signs. But we're going to show the division. That gives us the positive value of the absolute value of x minus 1/2 equals negative 7/2. All right, so we can take two steps. We could set this equal to positive and negative, or we can notice that, hey, wait a minute, absolute value can never be negative. There is automatically no solution. So this is an equation that has no solution. But remember, there are rare instances in absolute value equations, usually when you have expressions on both sides, where you can get an answer. And then when you plug that answer in, you see that it makes the right side negative. That would be an extraneous solution. So it is possible to get solutions that don't actually work. Those are called extraneous solutions. They're also called a pain in the neck, because unless you check, you don't know that they're fake solutions. So please, please check your answers. All right, we're not going to get into graphing these in this video. Look for that in another video. Remember, if you're going through your classwork or a module on this website, or you're studying for a test and you come across an absolute value question that is just ugly and you don't know how to do it, you should be subscribed to our YouTube channel. It exists for you to send in any problems you're having trouble with. We will make a custom video solution for you, and you will know how to do it. Until next time, Math Hoppers, take it easy.